Hello, and welcome to Chapter 4, Section 3. Today we are talking about two more types of distributions for finding probabilities. So last section we talked about binomial distributions. Today we have geometric and Poisson distributions. So for these two, they're slightly different. They're kind of like the binomial one where there's like special rules for each one, but then the information given to you is going to be different. And so I'll show you how to tell the difference between each one. So the first one I want to talk about is the geometric distribution. So the main difference when we're talking about geometric distributions is that they're not going to give you an n. Remember, n in binomial stood for like the total number of trials, and there had to be a set number. Well, in geometric, there is not. You can actually have like an infinite number of trials that you do in total. And so because geometric, basically what we're being asked about is like how many trials we fail until we get a success. So when we talk about our x variable, x is going to stand for the trial number where the success first occurs, which means you're going to fail a bunch of times, and then on whatever x value that they ask about, that's where we finally get a success. Same thing as before, we have to have independent trials and then the same probability of success for each trial. So those two rules are exactly the same as binomial. But the main difference is that there's no n, and then x stands for not how many successes you want, it's the trial where your first success occurs. So the formula for finding the probability of a geometric distribution looks like this. So we're going to have the probability of where the x variable, the random variable, equals x. So this small x is the number that they're actually asking you about in the question. And then the formula itself is we're going to take Q. So remember, Q is the probability of failure. So if you take your probability of success P and subtract it from 1, that'll be your probability of failure. Raise it to the power of x minus 1. So basically we're saying like if let's say x the question is asking about like getting a success on the 5th try. That means if you get a success on the 5th try, that means the first 4 attempts that you do have to be failures. So that's why it's x minus 1, because like the 5th try minus 1, the first 4 are failures. That's why it's cute. Then on the 5th try, you actually get a success. So that's why we multiply by the probability of success there. So let's try it with an example. Basketball player LeBron James makes a free throw shot about 74% of the time. So right there, that's our probability of success. Find the probability that the first free throw shot LeBron makes occurs on the 3rd try. So that means if you're succeeding on the 3rd try, that means your first 2 have to be misses. So for this problem, we're going to have x equals 3 because we're trying to find the probability of the first free throw shot on the 3rd try. Then our probability of success is 0.74. Q would be our probability of failure, so 1 minus 0.74 is 0.26. So following our formula now, we want our probability of failure to be 0.26. We're going to raise this to our x minus 1 power, so 3 minus 1 is 2. And then we're going to multiply that by our probability of success, which is 0.74. So doing that in our calculator gives us a probability of 0.050024, so about 5% pretty much. So that would be the probability right there. Another example, find the probability that LeBron takes at least 3 free throws to make his first shot. So this is a slightly different question now. So if he wants to take at least 3 free throws, that means he basically has to take 3 or more in order to actually make his first shot, which means we're saying that we want x to be greater than or equal to 3, because that's 3 or more. But remember how there's no set n here? So the maximum number for what x could be any number bigger than 3. So if this goes on forever, it's hard to just keep adding numbers together. Like we could go like find x equals 3, find x equals 4, find x equals 5, and add those up. But we'd have to do this forever, which doesn't make sense because we can't do something for forever. So instead, what we can do is basically we don't want him to make his first shot and like miss none, or we don't want him to make it on the 2nd shot. We want him to make it on the 3rd or more. So if we subtract out the numbers that we don't want, because we don't want him to make it on the first shot, we don't want him to make it on the second shot, then if these are the numbers we don't want, we can subtract that from 1 to find the rest of our probabilities, because this will give us the numbers for x equals 3 and onwards. So doing this, we can plug in the formula for x equals 1 and then plug in the formula for x equals 2, or the shortcut way would be to use our calculator, of course. So when you bring up your calculator, and this will work for the first problem that we did as well too. Second vars, because this is where we found our binomial CDF and PDF, but we're looking for, if you scroll up, there's one called Poisson Pdf. Oh, sorry, we're on geometric. Geomet PDF, Geomet CDF. So PDF is like if we were to do the first one, where it's just asking for x equals 3, for just one number. CDF is, it's always going to start adding for x values from 1 up to whatever number you type in. So I'm going to use CDF right now because I'm trying to figure out the x equals 1 and x equals 2 together. So my probability of success was 0.74. My x value here is 2 because I don't want the numbers x equals 1 and x equals 2. So Geomet CDF will add up x equals 1 up until x equals 2 for me. Paste. When I find that probability, I get that. But remember, we wanted to, these are the numbers that we don't want. So we're going to subtract this from 1. So 1 minus the answer I just got. So this will be the probability of him making his shot at least 3 tries in order to make his first shot. All right, the last part of our notes, we are talking about a different distribution now called Poisson distribution. So Poisson is where in the problem, instead of giving like any type of number of trials, you're going to be given a mean instead. The other difference is that now we're talking about intervals of time. So it's like how many times did something happen within this certain interval of time. So our variable x is going to stand for the number of events happening within that given interval of time. So before I give you the formula, let me show you what the problem is going to sound like. So something like the mean number of accidents per month at a certain intersection is 3. So they're just saying within a month, the average amount of accidents at this intersection is going to be 3. But see how they give you the mean? That's the clue that this will be a Poisson distribution. Then it asks, what is the probability that in any given month 4 accidents will occur at this intersection? So now they're asking about 4 accidents. So that's like the x value you're using because that's what they're asking about in the question. So also notice in these types of problems for a Poisson distribution, they're not going to give you any sort of probability of success because we don't really have like successes or failures anymore. All right, the formula looks kind of crazy for this one. So let's say x is the number that they're asking about in the question. So e, I don't know if you've seen e before, but it's just a number. It's kind of like pi, where pi stands for the number 3.14159, blah, blah, blah. So lots of decimals after it. E is the same thing. It's just a different number. It's 2.71828, ... Like, again, the decimal doesn't end. It just keeps going forever. That's why we don't actually write it out. We just write e. Okay. So e is being raised to the negative mu power. So mu is going to be the mean that's given to you in the problem. So when you do this calculation, you're just looking for the e button in your calculator and then raise it to whatever exponent. Then you're going to multiply that by the mean number raised to the x power. So the x is like whatever number they're asking about in the question, divided by x factorial. So it's been a chapter. But remember, factorial is like where you're multiplying all the numbers below it. So like if x is 4 or something, then you would multiply 4 times 3 times 2 times 1. Okay. Or if you don't want to use the formula, you can use the calculator. So in the calculator, you'd be looking for Poisson Pdf or Poisson CDF. So if we go into second vars again, scroll up, you'll see Poisson Pdf, Poisson CDF. So just like the binomial PDF CDF and the Geomet PDF CDF, CDF is the one that like keeps adding numbers up for you. PDF is like when they're asking about one specific number in the question. So one specific value for x. So like our question, the mean number of accidents per month at a certain intersection is 3. So that means the mean is 3 here. And then the number that they're asking about is the 4 accidents that will occur in the given month. So that given month is like the interval of time that they're asking about. And so that part doesn't really like do anything to the problem really. It's just, that's how you can tell this is going to be a Poisson distribution, when they give you the mean and they give you like a time period. Okay, so plugging into the formula, and then I'll show you also how to do it in the calculator. All right, so plugged into the formula, we have e to the -3 power, because the 3 was our mean, times 3 to the 4th power, because our mean raised to the x power, all over 4 factorial. So doing this in the calculator, let me get out of this first. So we have the E button in the calculator is right above the LN button. It's in blue, so it'll be second, that. And it automatically does it to a power for you. So we want a power of -3. So make sure you're using the negative button and not the minus button when you do this part. And then we're going to multiply it by 3 to the 4th power. So the exponent button, if you don't know, is this little like arrow thing. Okay, I'll find that number first. I get some decimal, cool. We are dividing by 4 factorial. So 4, and then the factorial button is found under math. Go over to PRB. It's the 4th one. And then enter, we get 0.1680. So we can also do this in the calculator using Poisson Pdf here, because we're just being asked about one number where x equals 4. If this was like x is greater than 4, x is less than 4, then we would need to use CDF for it. So in the calculator, second vars again, we find my Poisson Pdf for just one number. So this symbol here, that's our mu. It looks weird in the calculator, just go with it. So our mean was 3. And then the x value they're asking about is 4. Paste, enter, there's that same probability that we got. So again, if they're asking about like less than 4, where you would add up everything from 0 up to 4, then you would use Poisson CDF instead. But yeah, that's it. Thanks for watching. Bye.